All right, so one of the cool things we can do in this chapter is solve more complex equations, like this one right here. I got a seventh plus 27 over x equals 1 over 7x. So what I want to do is I want to get rid of all the denominators in this problem. So let's take a look. I'm basically going to multiply each one of these by a number, and my idea is to get rid of those denominators. So when I do that, the number I'm going to have to multiply is definitely going to have a 7 in it, so it cancels out this one. It's also going to need an x in it, so it can multiply and cancel out this one. And this one, oh, it's going to need a 7 and x, but I already have those two. So this is sufficient to get rid of everything, basically. Okay, so now when I do my multiplication, one way to think about that is I can bring the 7x into all of these, right, like this. And kind of see what cancels. So in this one, just the 7 cancels, and I'm just left with 1x. This time, the x's will cancel, and I'm left with 27 times 7. Let me just pull out my phone and do that calculation. 189. And then this one, the 7's cancel and the x's cancel, so I'm just left with 1. So all I need to really do here is subtract 189 from each side, and I'm going to get x equals negative 188. This time there wasn't that much that canceled out, right? Like it wasn't that hard finding the number to multiply by. But let's look at one like this. Let's say we had like x over 15 plus x over 12 equals a ninth. Right? Okay, so I want to cancel these all out. Well, it's kind of hard to work with them if they're all if they're like the full numbers, right? So instead, my first step is going to be rewriting this as, and I'm going to break apart those bottoms. So 3 and 5, 12. If you need to do these on the side, that's fine, right? 12 is just 2 times 2 times 3, and 9 is just 3 times 3. Okay, so what I want to do is I need to come up with a number, so I just transform that. I need to come up with a number that's going to break apart all of these. So to break apart the first one, I know it's at least going to need a 3 and 5, so the 3's and 5 will cancel. So when I go to the second one, the 3's will cancel, but I'm still going to have 2 2's on the bottom, so I'm going to need to bring 2 2's. Oh, I'm off the screen there. So I'm also going to need to bring 2 2's. And when I go to the last one, right, I have the 3 already, but that's not going to be sufficient, right? I need to have 2 3's cancel out, and I only have the 1. So I'm going to actually have to add in a bonus 3. So I'm going to multiply this number by all of them. Right? And let's see what cancels. So in this first one, I'm going to have the 3 and 5 cancel out. Right? So what's left over when the 3 and 5 cancel out is a 2, a 2, a 3, and an x on top. So 2 times 2 is 4, plus times 3 is 12. So this thing is going to become 12x. When I go to the second one, I'm going to have a 2, a 2, and a 3. So basically all of this, right, cancel out. So what I'm going to be left over with is a 3 and a 5. And I have an x up top, so 3 times 5 is 15. So that'll be 15x. And when I go to this last one, I'm going to multiply. Well, now the 3 and the 3 are going to cancel out. And what I'm going to be left with is this chunk. 5 times 2, which is 10 times 2 is 20, times 1 is 20. So this is the difficult part, getting to this equation. Now it's an easier equation to solve. That's 27x equals 20. I'm going to divide both sides by 27, and I will get 0.74, 0 repeating, right? Cool. And that's how you do it with these kind of more complex ones, when we try to make a new, easier equation to solve.